Good evening, everyone. Yeah, am I audible to you? If I'm audible, could you please put a message in the chat box so that I can ensure that I'm audible to it? Okay, fine. The screen is also visible to everyone, I hope. Okay, so let's start our class. Today's session, we are going to discuss the chapter Force and Pressure. I hope this chapter is already completed in your school, right? Today, what we are planning to do is we are just going to revise all the concepts and we will discuss a few questions so that the concepts are clear for you people. Okay. So in mid of the class or at any time, if you're feeling any doubt, please put that in the chat box so that I can get back to the questions and I can answer maximum. Okay. Is this much clear? Please don't be scared at all. Please be free to ask any kind of questions you can put in the chat box. Due to the inconvenience, I won't be able to unmute everyone and make you people speak. So you can put your messages in the chat box. So I will have a look on it. And at the same time, I will reply to all of your doubts. Okay. Can we start? Okay. So yeah, let's start with the class. Before moving into the class, let me ask you a question. Do you like this chapter? Is this chapter easy? It's very easy. Okay. So that means I need not explain in very detail because you people already know the concept, doesn't it? Okay, it's okay. Okay. Only we can say that the amount of numericals is that something which scares you people a lot, isn't it? When you hear the name physics, a lot of numericals, a lot of multiplication comes up, a lot of equations. But in this chapter, it's more the concept. Okay, than the numericals. Okay, each and everyone is saying it is easy. Okay, fine. So let's see how much we are going to enjoy this session. So first of all, we have learned about forces, isn't it? We have heard about many kinds of force. So if I'm asking you a definition of force, what would you give? In simple sentence, you will say it is a dash or dash. What is a force? Yeah, it is a push or pull. So a force is simply a push or a pull. So you know whenever you get into some buildings or that means something, when you get into there will be the door and it will be written as push or pull. When you open it can be sometimes push, it can be pull also. That depends on the direction from which we are opening the door, isn't it? So the mainly the forces we can categorize into two, which is push force and the pull force. If you look at this image, if you are looking at this image also, one boy is actually pushing the sofa, right? This boy is actually pushing it off. What the other one is doing, other one is actually dragging it up. He is actually pulling it off. Whatever it be, it is a kind of force. It is a pull force. You can imagine in this way also, whenever you see a football match, the players will give a kick to it, or we can say that we use many kinds of verbs such as picking it up, pushing it up, pulling it up, isn't it? So a lot of verbs we use. If we want to move one object from the other place, means one place to another, if we want to move one object from the other, and you know what are the effects of forces, isn't it? So if we want to all of these things, what we'll do, we will actually apply a force. So force can be actually considered to be two kinds, that is push force and pull force. Okay, now let's move on. So if I'm giving you a few examples, if I'm going to show you a few example, would you be able to say which among that is a push force and a pull force? Okay, that's the next question that we are going to do. So I have shown you a few images over in the screen. Okay, I hope you can see the screen with the images, isn't it? I'm going to number it off. Okay, first one. This is the first image which I'm showing to you people. Could you say whether it is a push or a pull? Okay, it's a pull. Fine. What about this one? Is this a push or a pull? Okay, excellent. Very nice. Okay, what about this? This is something which we actually encounter whenever we are doing something. Nowadays, we have a touch screen only, then also. Okay, that's also a push. Okay, So we came to the conclusion that means all of you give me a correct answer. This is a pull force and this is a push force. What about this? This you people all said that this is a press or a push. Yeah, correct. So when in olden days means in earlier times, now also it is there, but you might not be much familiar with those kinds of keypad touch fonts means keypad fonts. So whenever we are pressing a button on it, it is press or it is a push. That's also a kind of push force. And if you observe this also, this is something which you people do regularly, right? Whenever you are going to plug in, yeah, whenever you are going to plug in something, you are going to apply a push force. What about if you are withdrawing it? What about if you are removing these plugins from the socket? Yeah, then it's a pull. So push, we will push it to get into the socket. And if you want to pull it up, what we will do? We will actually pull it up. Now, the last image which I'm going to show you is a combination of both. Okay, so if I'm marking this as 1 and 2, the horse is actually pushing the cart or pulling the cart. What is that? It is pulling. Okay, fine. What about this person doing? Is this person pulling it or pushing it? Yes, it is pushing, right? So I hope what the you are clear with the idea of what is a push and what is a pull, isn't it? Okay. Now let's do, I will give you one more question of the same type. Let's do, state whether the following statement is true or false. To move a loaded trolley, we have to pull or push it. Do you agree with the statement or any other different opinions? True. Okay. That means if we want to move that trolley, whatever it be, if you want to loaded one or an unloaded one, whatever it be, we need to apply a force to it, isn't it? Then only we will be able to move it from one place to the another, isn't it? Okay, now let's move on. I hope this much is clear. Very interactive students. Glad to see you all here. Now, now we know that I have shown you a few figures over the screen. Okay, one person is standing over here and the other is a chair. Okay, if I'm asking you, is there any force exerted by this man on this chair? Any force? Is a man means exerting any? Okay, no. Why it is not? Okay, you can examine the second figure also. There is a car over there as well as two persons are standing off, isn't it? Are these persons exerting any force on the car? Are these persons? No. Why? Any idea? Why they are not exerting any forces? Any idea? Hmm? Any idea? Because if a force, correct, if a force needed to be act, yeah, correct, they are not touching the car, they are not pushing or pulling it, correct. These definitions are very true. So if a force needed to be acted, means if there is a force to exist, then there should be the interaction between the two objects, isn't it? That means the person and the chair. If the person is going to sit in the chair, means sit on the chair, then yes, then there is an interaction, which means that that is an interaction. Okay, which means it is a force, there is a force acting. Same way in this case, in the second case, if the two persons who are talking to each other is trying to push the vehicle from one point to the another, then also there is a force there, isn't it? So if the force needed to exert, then there should be some sort of interaction between two particles. Okay, it can be two or more particles, but between these two objects, what should happen? Some sort of interaction should happen. Otherwise, this is not an there will not be any force and there will be no effect of any force. Okay, correct. Very good. Now, as we say force, okay, you might have, since the Onam has passed on the last month, you people have played the Vadamali, right? It is a very interesting game which we do in our times, right? I mean, it's our own celebration Onam and it's our game to do. Yeah, what? Okay, we all play Vadamali. So how it is done means there will be a few people standing, isn't it? The group can be as much as large. There is no problem at all in that. And a few people will be standing at this point and a few will be standing at the other point, right? Here now there are 3 and 3. But the number of people is not going to make any difference. What is the difference they are going to make? The one who exerts a greater force. That means if these 3 are exerting a greater force and pulling it down, then this party is going to be win, right? They are going to be the winners. But what about this? If they are exerting a larger force to this end, then what will happen? Then definitely they will win. But my question is, if both of them exerts equal amount of force, then what will be the result? Who will win? Then who will win? It will be a tie. Okay, they won't win. Fine. No one will win. Okay, fine. Why? Will there be any movement in the rope? Means from the position where we are standing? No, na? Not at all. Why? Because that is a balanced position. Whatever force is exerted by one side is being cancelled by the other. So when this becomes, means if at till that moment when it is, can't predict. Why? If both of them are having the same exerting force, both of them are exerting the same kind of, mean same amount of force, we can say that we know the unit of force, right? If the first side is exerting a 5 Newton of force and the opposite side is also means exerting a 5 Newton force, I'm saying all of them together. If there are 3 persons together and 3 of them together are exerting a force of 5 Newton in one side, and in opposite side also they are actually giving out a force of 5 Newton. That means both the ends the force are the same, isn't it? That means what will happen? It will not move at all because the net force acting on them is 0. Why the net force acting on them is 0? Because the forces are acting on 2 different positions, right? 2 different direction, not position. They are acting on 2 different direction. For example, this boy is making 2. This is 2 Newton. This is 2 Newton, and this is 1 Newton. Okay. What is the net force then? Since all of them are applying the force in the same direction, what will happen? They will get added up. That is 2 plus 2 plus 1. That is going to be 5 Newton. Right. Very good. Very good, Anne. Okay. Now, same way, if these 3 students, if there are these many students, I mean, not students, they are children, means children only. So if they are exerting the same kind, 1, 2, 2, what will happen to them? Again, all of them are exerting the force in the same direction, which is towards this end. So this will also add up to be 5 Newton. Now let's consider the total sum. Altogether, this is 5 Newton, which is acting towards this side, and altogether this is 5 Newton, which is acting towards the opposite side. So when we encountered the earlier situation, the force was exerted in the same direction, and all of the individual forces got added up, isn't it? Now, in this case, what will happen? No, yeah, this is a mistake which we usually encounter. Now, in this case, 5 Newton is acting towards this side and the other 5 Newton is acting towards the opposite side. So, whenever we come across with forces acting on 2 different directions, we have to actually subtract it. That means 5 Newton minus 5 Newton is 0 Newton. That is, there is no net force acting on them. Hence, nobody will win, nobody will lose because they will be at the same position. Clear this much? I hope this much is clear. So let's move on. Means I'm not moving on, just summarize what we have learned till now. We learned that force is a push or pull, and we try to distinguish between push and pull. Then we were speaking about the forces, isn't it? That is, direction of force we were particularly considered. That means if the force is acting in one particular direction, then we need to add up the forces. If they are acting in the opposite direction, then what should we do? Then we should subtract it off. Is this much clear? Could everyone please reply? Yeah, I got Brinda, Anne, okay, Akshat, Utipa, Atid. Okay, fine. So you people are clear with the concept, right? Okay, now let's move on. Now, Same way, this is another game which we do, the bristling, or you call it as punch game or something. Okay, so if the two persons are competing with this, the person who is exerting a greater force will win the game, isn't it? The person, again, in this case also, we can consider an example. For example, if I'm naming this person as 1 and this person as 2, this person is exerting a force of 2 Newton, and this person is means exerting a force of 1 Newton. Could you please say the which player is going to be the winner, 1 or 2? Is it the player 1 or 2? Yeah, because the 1 is exerting a greater one. So definitely the first player will win. Okay, now let's move on to further. Okay, same way. This is the other case. In the previous two cases, we consider the force which is acting in two opposite direction. Here, if you look into, the three persons are actually pulling the rope, isn't it? And they three are, means three of them are exerting the force in the same direction. So if the person is having a 4 Newton, applying 4 Newton, and the second person applying a 2 Newton, and the third person applying a 1 Newton force, could you please tell me what is the net force exerted by these three persons? Not really. It's not 6. Yeah. Okay. Okay. Good. Okay. Very nice. Okay. So everyone got the concept, right? So if the force is acting in the same direction, then what should happen? Then it should get added up. And if the force is acting on the opposite direction, then they needed to be subtracted. Okay. Clear? Now let's move on further. Next is effect of force. This is something which you people might enjoy, right? Because you people watch football, you people watch cricket, isn't it? So when there is a, imagine that is a penalty shot going on. Okay, the players are going, I mean, coming and standing in a row, and there is a football in front. Okay, what will happen then? Any idea? See, if this is the situation, and now can you say me the state of the football? Is it at rest or is it in motion? Before the penalty kick? Are they at rest or in motion? Rest. Okay. Now, my next question is, what do you mean by the state of rest? Rest or motion? Okay. What do you mean by the state of rest? If the body, yeah, if the body, when it doesn't move, so that means if the body is not moving, which means that its speed is 0. When the speed is 0, then it is known as the state of rest. Okay. A body can exist both in its state of rest as well as in its state of motion also. Okay. So in this case, now the body is at the state of rest. That means the football is at the state of rest. Now imagine that one of this player is coming up and he is giving a click. Sorry, he is giving a kick. Now what will happen? Will the state of motion change from rest to some other? Will the Yes, it will change. Okay, so what will be the change over here? Initially, the football was in a state of rest. Now, what will happen? It will be in a state of motion. Okay, clear? So there is a change in a state of motion. Change of rest means it is changing from a state of rest to change of motion, right? Now, same way in this case also, let's consider one more example. In the previous one, see, in this case also, a toy car is at rest. A boy is actually applying a push force. Now what will happen? Initially, the toy car was in the state of rest and now it began to move. So after applying a force, we can say that, yeah, we can say that there was a change in the state of motion. Okay. In the second example also, a ball is being thrown. Now this boy is actually trying to catch it up. That means actually the ball is coming in which direction? The ball is actually approaching the boy. It's in the direction shown by the arrow. Now, what is the force applied by the boy? He is actually applying an opposing force, trying to catch it down, isn't it? He's trying to catch it down. So what will happen? It will get nullified and the body will come into rest. So initially the body was at the state of motion. Now what happened? Now it came to rest. Okay. Now this is something which we in our means we can say that we in our childhood we play this game, that we will take one wheel and we will use a stick and we will make it as a competition. That is, there will be 4 to 5 people standing up, brothers, sisters, cousins, sister, everyone. And the competition is that the person who makes that wheel travel the fastest will be the winner. So in this game, the most important thing is to use the stick properly. That is, if we are actually giving the push force at regular intervals of time of this wheel, its speed will increase. So the person who is able to control its speed, that means the person who is able to increase its speed at regular intervals of time, will be actually the winner. Okay, so what does that indicate? A push force. Whenever we are tapping the stick on the wheel, what does that indicate? We are actually applying a force on it, isn't it? So what does force do there? It is increasing the speed. As well as in this case also, you can consider when a penalty kick is done. Here is the goalie, means goalkeeper standing, isn't it? And yeah, correct. So when the keeper is there, he is actually applying a force in the opposite direction of the motion of the football. What is the direction of the motion of the football? This way. And how will the this one change? This is means the goalie is actually opposing the force of it. Hence, as a result, it can be brought into the state of rest. Okay. So what did we understand? Means what did we understood from these examples? We discussed four. What can we conclude from this? The state of motion, state of rest we discussed. So what can we conclude from this? Force can actually change dash of motion. Come on, let's say. Yeah, state of motion. Good. Okay, good. That means it is not necessary the direction need not be changed. The speed can also be changed. That means either the direction should change or either the magnitude. That means either the speed should increase or decrease. If or these both can happen. So if all of these can also happen. So either the direction should change or the speed should increase or decrease. If any one of these happens, then we can say that there is a change in the state of motion. Clear? Can we move to the next? Okay. What is the next effect? Have you ever encountered this? I don't think you people have. Have you seen a potter making pots using clay? Have you? Yes, you have. Okay. Have you ever tried it? That's my question. Have you ever tried it? Have you ever tried to shape a pot using this wheel? No. Yeah, okay. No, but it's actually a wonderful thing to notice. If you can visit a nearby porter or something, you can just have a look or you can check for the videos in YouTube so that you will get a clarity of this. Means whenever the porters are making a vessel out of the clay, they will actually initially they will be playing only a block of clay. And according as the wheel rotates, they apply a force. Means whenever wheel is rotating, the wheel itself is exerting a force, and according to that, our hands, means the potter will use the hands to shape the vessel. So what is the effect of force there? The vessel can be molded into any shape by applying suitable force on it. Okay, same way. This is something which you people have tried and you usually encounter in the kitchen, right? Whenever chapatis are made or whenever puris are made. Okay, I know that's your favorite dish. So whenever these things are made, what do you do? Means to make the dough softer, we'll smash it, we'll kick it, we will make it smoother and smoother by pressing it hard, isn't it? So by doing so, we are applying a force. And what are we doing actually? When we press it hardly, there is a curve formed there, right? There is a curve formed there. So what does that convey? Again, when force is applied, there is a change in the shape. And the third one, most familiar, after having a cup of, means after having a bottle of water, you people might have done, you will just squeeze it off, isn't it? You can hear a variety of sounds while squeezing also. So whenever you squeeze these plastics, again, what will happen? What is the change there? The shape changes. As well as a spring. When you consider a spring also, a spring can be stretched, isn't it? When we remove the force, they will come to the original shape. This can be examined in sponges, right? Whenever pillows are made, when you have a pillow fight with your brother or sister, you see the pillows changing, right? Because pillow is made up of very delicate sponges, right? So sponge will change the shape. So another effect of force is that it will change the what change? It will change the shape. So what are the two effects of force? Could you please reply in the chat? There are two effects of force which we'll discuss just now. So what are the two effects of force? Okay, good. Uthiba, good. Nice name, Uthiba. I'm hearing that name for the first time. Abraham, good. Then we learned two. You people are giving me only one. So I want both of them. Abel. I'm not wrong, right? If I'm pronouncing it wrong, please let me know. Abel. Then Akshat I got. Ameya, could you reply? Have not seen Ameya's reply till now. Aromal, Flora, Roshan, Srinithi. Okay. Okay. Now replies are coming up. Yes, Srinithi, you do have a doubt. Okay. So I hope this much is clear to everyone. Is this much clear? Can we move on? Yes. Okay. Fine. Thank you all for your response. It feels very great when students are responding actually. So I'm glad that my students are responding. So hope you meet in the next class so that we can make it much more interesting next time. Okay. Now, the next thing which we are going to learn is different kinds of forces. Okay. Whenever you have a fight with your brother, you will give him very nice slap, isn't it? You are applying your palm on him. Means sometimes you might take a stick and give him a nice, right? So on of these accounts means whenever you are having a first fight with anyone, as well as means body fight, I'm meaning physical fight, as well as when the wrestling game you might be very aware of, you might have seen. So when these games are going on, we are actually using up our muscles to apply forces. Even you can imagine someone drawing water from the well. Imagine that someone is drawing water from the well. So we are actually using our hands to pull the rope down, isn't it? That means we are using our muscles to apply the force. So those forces which are applied by our muscles or with the help of our muscles are known as muscular forces. Now, don't underestimate that we only have muscle. That means human beings are not only the creatures who are making use of muscular force. We know bullock carts, isn't it? Bullocks also pull the heavy cart using their muscles only, isn't it? So all of these forces means whenever we take the help of our muscles to apply some sort of force, then we call it as muscular force. Okay. Now you will think that we are actually voluntarily we need to apply some forces. There is we do have that in our mind and then we are applying forces, right? But there are certain things which is happening in our body. You might have learned it, voluntary and involuntary actions, right? In that cases also, there are many times when the muscles react accordingly. For example, you are having your food. Okay, imagine that you are having your food. So food needed to be digested. For that purpose, what should happen? The food should reach the stomach, right? So when how will the food reach from the mouth to the stomach? It is because of the help of the muscles over there. So from the esophagus to the stomach, the journey is accompanied by the motion of the muscles, as well as, okay, as well as we inhale and exhale, right? Because it's very important. We are breathing in, we are breathing out. Okay, whenever you breathe in, you can see that your ribs are coming out and coming, means it is expanding and contracting, right? We can examine now itself. Take a deep breath, it is going inside. Relax, then there is an expansion and contraction going inside your lungs, isn't it? So what is there happening? Who is making that motion possible? That's also done by muscles only, isn't it? So all of these actions are actually controlled by the muscles. So we can say that these forces are exerted by the muscles. So these forces are known as muscular forces. Clear? Okay. I hope this much is clear. Now, next kind which we are going to learn is which one? The frictional force. Imagine that you are having a toy car in your hand. Okay, you are having a toy car in your hand, and what is happening? You people are winding it full key, means fully winded up, and you are putting it in the floor. What will happen after some time? It will come to rest. right? Okay. So why does that come to rest? Or else we can put the question this way, that what makes it stop? The picture itself, the image on the screen itself gives a clear picture. So my question is, how does the toy car stop? Or what is the reason? Yeah, good. It is because of friction, isn't it? Now, what do you mean by frictional force? Frictional force is just the opposing force, isn't it? It is the opposing force which is acting upon. As shown in the figure, in this figure also it is shown, motion is in this direction, right? The boy is trying to push the body. That is, he is applying force in this direction. Now, when it is a smooth surface, we'll be able to push it very easily. But when it is a hard surface, that means when it is a rough surface, it is very difficult for us to push it off. Why? Because the friction is more there. There can be another example also. If some oil is spill on the floor, okay, when you step into it, you will easily fall. Why? Because oil reduces friction. But if there is no oil at all, then there is the chance of slipping off is very less. Same applies to wet floor also. Whenever there is rain, your mom or your dad always says to you people to walk very carefully. Why? Because there is a chance of slip. Because the floors are wet. Why? The floors are wet because there means since the floors are wet, there is frictional force is very, very, very less. So the chance of us falling down is very, very more. Okay, so I hope this is clear. So frictional force acts in the direction opposite to that of the motion. So definitely you can remember in this way, a force, a surface and an object. For example, if there is a surface and there is a ball, we are trying to apply a force. At this moment, the ball is in contact with the surface, isn't it? The ball is in contact with the surface. That means whenever these ball and the surfaces are contact, there is friction acting. Whenever our applied force overcomes this friction, then only we are able to move this ball. You can imagine in this way also, whenever you try to push a heavy load, sometimes it's not possible. But when your father comes up or your mother comes up and give you people a hand to push, then what will happen? It will be easy for you people to, I'm sorry, it is easy for you people to push it off. Why? Because at that point, the force applied is more versus enough to overcome the frictional force. Okay, so frictional force is again a contact force. What do you mean by a contact force? That means the two bodies should be there in contact. Okay, then that is known as a contact force. So frictional force is a contact force. So whenever these two objects are in contact, when the surface and the objects are in contact, frictional force is acting on the opposite direction of the motion. So the force which we are applying should be enough to overcome it. Then only the body will move from one point to the another. Clear? I hope this much is clear. So we have discussed the frictional force as well as the muscular force, which are examples of contact forces. So whenever we are applying muscular forces, then that means we are actually using our hands, or we are using some of our body parts to apply that force, isn't it? That means there is a contact between them. So when it comes to non-contact force, what is the difference? There will be no contact between these two surfaces. For example, if there is a magnet, okay, I'm having a pole magnet in my hand, and I'm going to keep some iron filings over here. Okay, this magnet and iron filings are not in contact. Okay, even though they are not in contact, what will happen? They will get attracted and iron filings will get stick into the magnet, isn't it? Okay, since those two surfaces were not in contact, we call that kind of forces as non-contact forces. Okay, so I gave you one example of non-contact force, which is a magnetic force. Now, could you people give me an example of non-contact force? I would like to hear from everyone. So I need one example of non-contact force. You can't use magnetic force. Okay. A few people said gravitation, a few people said electrostatic. Okay, apple falling from tree, which is the force responsible for that? The reason why we are learning the laws of gravitation. So it is gravity. Okay, fine. So gravitational force is an example. We know that each and every body attracts each other, right? That is known as the gravitational force. That is why The apples fall down, the mangoes fall down, even the raindrops are falling down because of this gravitational force only, isn't it? At the same time, electrostatic force. What do you mean by this big electrostatic force? Any idea? Okay, imagine in this way. You are having a balloon, okay? It is inflated completely. And you are going to rub it with some sort of silk cloth or let it be. Rub it with a few times, rub it with silk cloth. Sprinkle a few small pieces of paper and bring it close to the paper. What will happen? The balloon will automatically attract the piece of papers. The same can done with your body also. When you bring a balloon very close to your skin, the hairs will get attracted, right? At the same time, you can try this also out. You are having a scale and try to rub it in your hair. Don't rub it within a very oily hair. I'm not speaking about that fact. If you are rubbing it on your hair for some time, and then if you are trying to bring it to nearly small bits of paper, what will happen there also? The papers will get attracted. So all of this is due to, very good, Adit Krishna, very good. So all of this is due to the electrostatic force. So what is electrostatic force? Electro means they are getting charged. That means whenever we are rubbing against another body, it will occur some charges. There are only two charges. This is some bit of extra information, which is quite out of your box. There are two types of charges. One is negative and positive. So negative positive will definitely attract. You know that north pole and south pole of a magnet will attract, isn't it? Same way, positive and negative charges will attract. Positive charges will repel. Negative charges will repel. Okay, so when both of them are having a opposite charges, they will definitely attract, even though they are not in contact. Whenever we are bringing the scale close to the papers, we are not touching the paper. Actually, it is having a fixed distance between there is a fixed distance between the scale and the paper, isn't it? So they are not in contact actually, but there is a force of attraction between them. So electrostatic force, gravitational force, magnetic force are examples of non-contact forces. Clear? So this is another example. Means, what did you get from this picture? This is something which we usually see, whenever we explain Newton's universal law of gravitation. Yeah, apple is falling down on Newton's head. Then only he thought that if apple is falling down, then why the apple is not going up? That's what he thought. And from that thought only we are learning, or we got into know about gravitational forces, isn't it? Now my question is, what is meant by contact forces? Give two examples of them. I would like to have the examples. Even though it is very difficult for you people to type the entire definition, it would be better if you are giving me two examples. Then I will make sure that you people have understood it. Can you give me two examples of contact forces? I'm particularly asking contact, not non-contact. Okay, good. Very good. Okay. Oh, okay. Okay. Srinidhi, could you particularly say which kind of force is that? Whenever you are pushing a car, that's a muscular force acting. Kicking a ball, that's also a muscular force act. Those are the instances. So the kind of force which are non-contact, means which are contact as muscular forces, and the one which we learned right now, the frictional force. Okay. Love to hear from you all. Let me catch up a few persons who didn't say anything till now. Akshad. Ameya, can you give me a hi in the chat box? I have not seen you yet. Ameya, are you there? And Flora. Okay, Flora. Okay. Flora, did you understand what I discussed right now? We are almost completing the chapter. Okay, fine. Vrinda. Okay, all others are means all of you are my good students only. All others have replied at least once. So I just called out someone who didn't say. Okay. Now let's move on. We are half done. So a force that can be applied only when the source of force is in contact with an object is called a contact force. Examples of contact forces are muscular forces and forces of friction. The force resulting due to the action of muscles is known as a muscular force. It is a force of friction between the surface of the ball and the ground that brings a moving ball to rest. So I hope this much is clear completely. Now let's move on to another wonderful topic which have a great application in our life: pressure. Okay, sometimes you must have heard this out. Whenever you are cutting, whenever you are chopping vegetables, the knife which we are using will have a very sharp edge. Why it is provided with very sharp edge? Same way, whenever you are trying to hammer a nail into a wall, the pointed end will face the wall. That means we are applying the hammer strike on the head part of the nail. Why the nails are very pointed? Why it is very sharp? Okay, say. Udiba, very good. Renta, good. Abraham, very good. Very good. You people know the concept very well. Yeah. Okay. Okay. Okay, fine. So let me explain for those who means for a better idea. Whenever the edges are very sharp, imagine the knife is having a very sharp side edge. Then we are applying the force. So the force only get distributed to that particular small area, isn't it? Right? So the effect of force is more there. We call it as the pressure. So since it is very sharp, the surface area of it is very less. Okay. Since the surface area is less, the effect of force over there is also more. Okay. So that means the pressure is more. Okay, clear. So to increase the pressure only, we are using sharp edges. That is applicable for the nails also. At the tip of the nail, if you notice over here, it is very small surface. Very small in this means very small means it is very small. As much the point is sharp, that much easy for us to actually hammer it off, isn't it? So the sharp edge means it is reducing the surface area, which will increase the effect of force, which we can say that it will increase the pressure experienced. Okay, pressure is force by area. So force by area means area is decreased, which means the pressure experienced is more. Clear? So that is why the knives are having, smaller means very sharp edges, and the nails are having very sharp edges. Okay, clear? Now, is the solids only making pressure? Does liquid exert any pressure? Imagine that you're having a column, okay, and I'm filling it with half of the water. Does blood exert pressure? Yes, blood exerts pressure. Okay, now I'm actually keeping up a balloon over there. Only half of it is filled with water. Now I'm taking another tube, which I'm completely filling it with water, and I'm having another balloon over here. My question is figure 1 or figure 2. In which figure will the balloon will expand more? 2. Why? Yes, in figure 2, the blood, sorry, the balloon gets inflated more. What is the reason behind it? Because, yeah, because it has more water. Water is liquid only, right? So the liquid exerts pressure on it. So because of the pressure exerted by the liquid, the balloon gets inflated. That means whenever the amount of liquid is more, the pressure exerted is also more. Okay, is this much clear? So liquids also exert pressure. Okay, liquids also exert pressure. So let's see one more example. We are taking a bottle over there. Okay, water is filled. And in the previous one, we have kept the balloon beneath, right? At the bottom of the bottle. Now, what we are trying to do is we are trying to make a hole on the side and we are inserting a small PVC tube and a balloon is fixed over there. Now, will the balloon will get inflated? That's my question. Or it is possible only if the balloon is kept at the bottom. Will the balloon get inflated? No. Okay. Yes. Okay. I mean, yes. Okay, fine. Okay, actually, it will get inflated. Why? Because the liquid actually exert pressure on the walls of the container also. It does not apply only downwards, it applies the pressure what sideways also. So if, since the pressure is exerted sideways, the balloon gets inflated. Clear? So the liquid exerts pressure on the walls of the container also. Now my next question is, if liquid exerts pressure, will gases exert pressure? Will gases exert pressure? Yes. Okay. Gases will also exert pressure. So we came to know that liquid exerts pressure as well as gases will exert pressure. Then my last and final topic here is, what do you mean by atmospheric pressure? We what is atmosphere? It is just the envelope of air surrounding the earth, right? Means means there is an envelope, there's air surrounded all over, which is definitely a gas, right? So this gas will also exert some sort of pressure. So the atmospheric air extends many kilometers above the surface, and the pressure exerted by this air is actually known as the atmospheric air. You might have noticed the suckers, vacuum suckers, which are used, isn't it? When you keep it on the wall, what happens is, there is a wall over here, we are using a sucker over here. What will the sucker do? It will remove the air from these gap. Okay, now what does atmosphere do now? Now the atmosphere applies the forces and it will stick onto the wall. So now you can imagine how much more is the atmospheric pressure is. It is very high. Okay, so atmospheric pressure is the pressure exerted by the atmosphere. Clear this much? Okay, I hope this much is clear to everyone. Is that? Could you please give me a word to review my class? Means you can use one word to describe how the class was. Just one word. I would like to know whether you people have understood or whether it was okay. Thank you, Rinda. Okay, fine. So the concept were clear, right? Okay, thank you, Akshad, Utiba, and thanks a lot. Flora, are you there still? Thank you, Abel. Thank you, Abraham. Thank you all. So see you in the next class. We will be discussing in the next chapter in the next class. So don't miss it. Okay. Please be regular in the classes so that we can discuss more. We can do more questions. We can clear the concept. We can clear the doubts. Okay. So see you next time. Thank you. Bye. Good night. Thank you, dear.